We're going to talk about properties of exponents, and in this particular case, we're going to talk about powers to powers, and we're going to figure out how to derive the rule for this particular case. When I have this power of 2 right here on the parentheses, that means I have the parentheses twice. So I'm going to rewrite that as I've got these two sets of parentheses, and inside the parentheses I had an x to the third. And if I want to expand that out, what I'm going to do is say I've got a power of 3. That means I have 3 x's. So I'm going to write that as x, x, x for that first one. And I have a power of 3 here, and that means I have x, x, x for that second one. And in total, I have x to the 6th. Well, if we look at these different, right here, these two different powers here and here, and say, well, if I had this 3 back in here, if I have this 3 and this 2, how did I get to this 6 right here? Well, that would mean I'd have to multiply those powers, so I have a rule. And I'm going to write that rule down. My rule is if I have x to the 3 times 2, I'm going to get x to the 6th. And I'm going to write over here on the side what I did. So with powers to powers, I multiply the powers. Okay, well, if I know that that's the rule and I have exponential powers that are radicals, or excuse me, that are fractions, I can use these same rules. So if I have something like x to the 1/2 squared, I can take these fractions and I can use the rule. So this is really x to the 1/2 times 2. Well, if I want to write my 2 as a fraction, I can say, well, that's really 1/2 times 2 over 1. And then I just multiply the numerators and I multiply the denominators, so I'm multiplying straight across. So this is x to the 2 over 2, and that's just x to the 1. Okay. I can rewrite this guy right here in radical form because fractional exponents are really radicals. And so if I rewrite this, I have my x and my root is 2 and my power is 1, and this whole thing is squared. So I can rewrite that as a radical. And just like before, if I have a power of 2, I have the same thing twice, so I really have the square root of x to the 1 times the square root of x to the 1, and that means I have the square root of x to the 1 times x to the 1, and I'm using the power rule of I can add the powers. So I have the square root of x to the 1 plus 1, and that gives me the square root of x squared. Well, because the index and the power are the same, I can cancel them out. They're opposite operations. These right here, this is opposite operations. So I can just cancel those out and I get x as my answer, or x to the 1. But I could write this as x as well. And the answers are the same. I'm going to give you one more problem because it can get a little trickier. What if I had something like this? I had x to the 3 and x to the 6, and all of this was, I'm going to make this a y. Let's make that a y. A y to the 6th, and that's all to the 1/3. Well, I'm going to use the power to power rule, and the power to power rule means I multiply the powers. So this is going to be x to the 3 times 1/3, And in the denominator, it's going to be y to the 6 times 1/3. So what I'm doing here is I'm multiplying this power by this power, and that's what I ended up with here. And then I'm multiplying this power down here with the power, and that's how I got this one down here. So I'm just multiplying power to power, and this gives me x to the 3/1 to make that a fraction and 1/3. And in the denominator, I have y to the 6/1 times 1/3. It just makes it easier to see that I'm multiplying my numerators and then multiplying my denominators. This is x to the 3/3, which is x to the 1. And in the denominator, this is x to the 6/3, which I can reduce to, or excuse me, y to the 6/3. And this is y to the 2. And that ends up being my answer.